Okay, so welcome to Module 10 Smart Contracts, and this is the lesson 1, the first lesson, Simple Smart Contracts. And well, in this lesson, we are going to see the smart contract, the concept of a smart contract, and we are going to start writing our first and very simple smart contract. In this module, the idea is that you learn a little bit of all the machinery about the smart contracts, that at the end you are able to write and understand a little bit the smart contracts and integrate this technology into some possible application. Yep, this is the objectives. Just describe that you understand the concept of a smart contract, that you are able to write some smart contract, and also that you are able to compile and deploy and use a little bit a simple smart contract. Okay, so first let's define. Let's see what's a smart contract, and well, in general, before we go close to see what is a smart contract, let's say what are the main features of a blockchain. Uh, I mean, a blockchain is a super system to manage a state in the sense that is the most replicated system in the world, probably, with the highest possible availability. It is tamper proof. I mean, we cannot change past events. And public blockchains, the blockchains that have public networks, these are the most transparent systems in the world, meaning that when something happens there, I mean, it is seen by everybody. Okay. As a result, many attacks or many things are impossible or infeasible in a blockchain system. In particular, I mean, denial of service attacks are impractical in big blockchain networks, uh, because it is impossible to make the network go down, because there are so many. The network is so replicated that it's impossible to make fail most of the network. Uh, Also, censorship is impossible because as a user you have plenty of nodes to which you can send your transactions, and for this reason it's impossible that you get censored. Well, and well, so we have a very good system to manage a state, but blockchains are not just distributed data repositories. I mean, they can also define logic around the state, and the idea is, okay, what we're going to use the state. Obviously, to build a cryptocurrency, it's okay, but there are. Can we open this idea to more applications? And this was the idea of Ethereum back to 2013. The vision was to understand the blockchain as a global computer, in which you can create your own applications. Creating your own applications means that you can define how transactions are going to be processed. Uh, so, Ethereum sees the blockchain as a global computer. Okay, is and as you can do in a computer, uh, in blockchains that see the state as the state of a global computer. There you can also install. I mean, in a computer you can install a program. Here you can also install a program. Typically, we say deploy, uh, and the code of the program, or the programs that we deploy here, is what we call smart contracts, or and essentially these smart contracts define how transactions are processed. and this is the new idea that blockchains, let's say blockchains 2.0, like Ethereum, introduced the concept of smart contract. As I said, the idea of a smart contract is nothing else that a small program that allows you to define how transactions are processed. And and how we use these smart contracts. Well, the idea is that you before you can use the smart contract, you need to deploy the smart contract. Okay, so if you want to use a smart contract, you have to install the smart contract. But in blockchain, we don't say install, we say deploy. And how smart contracts are deployed on a blockchain? They are deployed through a transaction. We need to send a transaction to the network. This transaction needs to be included in a block and executed. And when it is included in a block and executed, then the code in this transaction, we send the code of the transaction, the code of the smart contract. And when this transaction is executed, then the code of the smart contract appears in all the nodes of the network. Okay, and in the case of the Ethereum network, that is the one that we are going to use as an example, this code is assigned an address like any other address in the system. Okay, and once the smart contract is deployed and is leaving behind one address, then we can send transactions to this smart contract. And what the transaction is going to do is going to be defined by the logic in the smart contract. This is the idea. Sometimes, the concept smart contract maybe is a little bit misleading, because smart, it's just a small software, so it's not so smart maybe. And contract, in fact, smart contracts don't have, they don't have legal validity. I mean, they are just code. Okay, we can provide this validity externally. Okay, we can go to a notary and say, okay, we're going to use this smart contract for our interactions, but by default, the smart contract doesn't have any legal implication. Okay. So to at this moment is a little bit abstract, the concept of a smart contract. So let's try to put an example and implement this example. Let's put an example, and then we're going to implement a simpler example. Okay. For example, let's see this smart contract. Or this is scenario. Okay, in this scenario, I have Alice. Okay, which is the account A11, sorry, and Bob and Carla. Okay, and what we want to build here is an application with a smart contract in which Alice is going to deploy a smart contract in the blockchain, is going to install this smart contract in the blockchain, to install the smart contract, Alice needs to send a transaction. This transaction goes from Alice. It will send the code of the smart contract, and it's going to send 10 ethers. Okay, so it is going to install or deploy a smart contract in the blockchain that is going to, and it's going to transfer 10 ethers to this smart contract. And the code of the smart contract is going to say something like, okay, this smart contract will send 5 ethers to Bob, 5 ethers to Bob, the account B9B, and another 5 ethers to Carla, which is this account CA7, but not until 2040. Okay, so and we can even make this a little bit more complex and say, okay, not until 2040, and for example, Bob needs to send a transaction, and Carla also needs to send a transaction to the network, so that they receive 5 ethers each. So Alice deploys a smart contract with this logic. Okay. After this transaction, the deployment transaction is executed, then it appears the smart contract, the code of the smart contract in each node of the network, and then, well, this smart contract will have 10 ethers each. I mean, 10 ethers is replicated simply. Okay, so the smart contract C71 will have 10 ethers, and then after 2040, Bob or Carla can send a transaction to this smart contract, see that the destination of the transaction now is the address of the smart contract, and then call some function in the smart contract to claim the 5 ether. Okay, and the smart contract is going to check that that we are beyond 2040, and it is going to check probably that it is this account, is Bob, who is sending the transaction, and then transfer the money to this account. Okay, so all the processing of the transaction is going to be defined in this code here. Okay, this is the idea of a smart contract. When we say that we send a transaction to an existing smart contract, in fact, concretely we are saying that we are sending a transaction to the address of the smart contract and to a specific function of the smart contract. Okay, this is how we use it. Okay, so but let's try to build and see. Let's see how to build a smart contract, and how to deploy the smart contract, and then how to interact with this smart contract once it is deployed. And first, let's see a little bit the anatomy of a smart contract. Which are the main parts of a smart contract? Well, the address of the smart contract. In fact, when I say smart contract, we need to create a program. The smart contract is nothing else than a program. And what we are going to create when we are programming a smart contract, in fact, what we are doing is create a template. Okay, and then when we deploy the smart contract, we create an instance, or we instantiate the template, and we can create as many instances as we want from one template. Okay, it's like when you have a contract between two parties, you have a template, and then you fill the names, for example, and so on. Okay, so we are going to program the template, and when we deploy the smart contract, we create a real contract or instance of a smart, or we are going to create instances of these smart contracts. Well, the smart contract, when we create an instance of the smart contract, it receives an address. It also has a balance. For example, I don't know, 0.5 ethers or 10 ethers or whatever. And then it has code. Okay. The code of a smart contract is a set of functions. And the code is immutable. You cannot change the code. The code are the rules that the smart contract is going to follow to process each transaction that it goes to one of these functions. So this code is immutable. You cannot change it. Okay. There is a very famous sentence in the Ethereum world that says code is low. And this is because in principle you cannot change the code of a smart contract. Okay. But the smart contract can store stuff that lives beyond a transaction. I mean, when we the code of the to make a smart contract work, what you need to do is to send a transaction to the smart contract. The smart contract is installed, or once the smart contract is installed or deployed on the network, on the blockchain network, then to interact with the smart contract, you need to send a transaction. And this transaction, as I said before, goes exactly to one of these functions. Okay, well, this during the execution of the function, these functions can update or modify the storage. The storage is like a persistent space in which the processing of a transaction can leave data that it is going to remain after the execution of the transaction. Okay, we're going to see we're going to see how to use storage in a moment. Okay, and storage is organized in a series in slots. Okay, and in a key value fashion. We are going to generate now a smart contract, and we are going to use just the slot or slot 0. Okay, the key 0, and we're going to put different values here. Okay. Okay. So now we can see the code of the previous example. Okay, remember that we had Alice, and Alice is like is like the mother of Bob and Carla. And Alice wants to create a smart contract. Alice will deploy a smart contract, and we provide funds with 10 ethers. Okay, and Bob and Carla can claim these 10 ethers, but it must be after 2040, and Bob and Carla, they are going to receive their 5 ethers each only after the other one has accepted the deal, let's say, by sending a transaction to the smart contract. Okay, and this is the simple code that we need for this. Let's just discuss it a little bit. Okay, so here we have the smart contract. The template of the smart contract is this one here, which is called Alice will. And then we have a couple of storage variables. Well, we are using 2 slots, slot 0 and slot 1. And in slot 0, we are going to store the fact that if Bob already sent a transaction, and we start with false. I mean, Bob didn't send any transaction, and Carla neither. Okay. I do this to be very explicit, equal to false, but in fact, well, if you don't put this, it's the same, because in this language, all the variables start with their false values. Okay, all the variables start with their false value, so it will be the same. Okay, but anyway, to be more explicit now, since we are starting with this, let's leave it. Okay, so, and here we have the 2 functions of our smart contract. They are almost the same. They are almost the same. I mean, they are the same. They have the same logic. Okay. I could also program this in another way, but since this is this is our first smart contract, I try to be explicit and make it simple here. Okay, so Bob, the idea is that Bob, after 2040, can send a transaction to this function here. Okay, what happens if Bob sends a transaction before 2040? Well, here we have the first this line here is saying, hey, the transaction that is trying to execute this function, okay, must be included in a block, okay, and check the block timestamp and see if this is beyond 2040, okay. If it is beyond 2040, okay, then proceed. But if not, this, when a require is not met, the transaction is reverted, okay. So here I'm encoding the fact that the execution of this function can only succeed if it is done by sending a transaction after 2040. So this is this line here, 13. And then I also require that the sender of this transaction must be this address. Okay, well, this is the address of Bob. And then I check if Carla already sent a transaction. If Carla already sent a transaction, it means that Carla managed to send a transaction that was processed. So send a transaction after 2040. So if Carla already sent a transaction, then I transfer to Carla, which is this address, and to Bob, which is this address, I transfer 5 ethers to each. If not, I cannot transfer the money. What I do is just say that, okay, Bob is okay with this sharing. I mean, send a transaction saying, okay, I want my 5 ethers. The problem is we're waiting now for Carla. Okay, and I put that Bob I store the fact that Bob said, okay, I want to receive my 5 ethers. And the other function is exactly the same. Okay, so but it's for Carla. So we check that it's Carla who is sending, and if Bob said okay, then we both, Carla and Bob both receive their 5 ethers. If not, we say okay, Carla said okay, we are waiting for Bob. Well, this is a very simple smart contract, and yeah, this is like a first example. Okay, we didn't discuss too much the all the syntax and so on. We're going to go. I'm going to build an even more simple example now. Okay, but this is just an example to see in a high level how to program a smart contract. Okay, but if I want to create a smart contract, what I need? Okay, well, I need some environment to write my smart contract. Okay, I need a blockchain network. And I need some way of deploying my smart contract and then later interact with my smart contract. So I need an environment to write my smart contracts, to deploy my smart contracts. I need some network to deploy my smart contracts in, and I also need after some way of interacting with my smart contract. This could be difficult or tedious, or yeah, but in the case of Ethereum, we have very great tooling developed by the people from the community of the Ethereum. So, and it is what we call Remix. Okay, well, let's go to writing smart contracts, and we're going to use Remix here, which is essentially a web environment in which when we connect to remix.ethereum.org, what we are doing is downloading an environment for writing smart contracts, and also this environment has integrated a very simple blockchain made of just one node. Okay, and we can deploy our smart contracts there and interact with the smart contracts. So let's build the simplest possible smart contract using Remix. And okay, I have here my browser, which is pointing to remix.ethereum.org. And you have this environment here. And if you go to the first icon here, okay, you have, you can create files here. Let's say first smart contract, or first dot solidity, okay. And as you see here, I have a text editor, essentially to write the template or the code of my smart contract. Okay, so let's see. What we're going to do is to build a very simple smart contract, okay, which is typically called a simple storage smart contract. Well, I call it first, but anyway. I call first to the file, but I'm going to call the smart contract simple storage. And the idea is that I'm going to use only one slot of the storage, and this slot, I'm going to refer to this slot through one variable that I'm going to call stored value. And slots of storage in Ethereum are of size 256 bits. And I'm going to interpret this 256 bits as a number without a number without sign. This is an unsigned integer. Int of 256 bits. Okay. So my slot, my storage, the storage of the smart contract is going to be just a box with a positive number. Positive number that goes from 2 to the power of 256 minus 1. Okay, it's a potentially, we can store a very big number here. Okay, so this is the storage of my smart contract. And then typically the way of designing smart contracts is to think about what do you want to store on the storage of the smart contract. This storage is persistent between one transactions and the next one, and then design some functions to interact with the storage. And if you think about this very simple example, you can think in many different functions, I guess. For example, set storage value. This function puts a certain value here. Okay, so when I send a transaction to this function is going to set a value here. Okay, for example, or get storage value is a function that gives me the value of the box. Okay. And we can create many more functions around this simple storage. For example, multiply by 2 the value stored or whatever. Okay. Well, I'm going to stay with these two simple functions because I want to keep the smart contract as simple as possible, just to see some of the details about how to write it, deploy it, and code it. Okay. Okay. So let's try to code this smart contract. Again, the smart contract uses one slot of storage that is going to store a positive number, an unsigned integer, and then we have two functions that of the smart contract that interact with this storage. Okay. Okay. So yeah, to start writing smart contracts, the first thing that we need to put here, recently there was a change in which all the smart contracts, it is nice that they start with the software license that they are using. So and you say this like this. Okay, this is the license identifier, and we call it meat, for example. Okay, I don't know, see if there is something wrong here. Oh, okay, well, this is okay. The first line of modern smart contracts contain the license of these smart contracts. Next, our smart contract, we're going to write the smart contract into a language that is called Solidity. And this language needs to be compiled finally to some code that is the one that we finally send in the transaction to the nodes. Okay, so there is a compilation here, and we need to the second in the next line we need to say or tell which is the version of the compiler that I'm using. Okay, well, I'm going to write the smart contract with some syntax, and this syntax is going to be understood by, and in this case I'm going to say that any compiler this exactly means that any compiler with version 0.x 0.8 whatever is valid. Okay, so the syntax that I'm writing in which that I'm using to write this smart contract is syntax that any .0.8 compiler can understand. Okay, and then how we write the smart contract, it starts with the keyword contract and then the name of the contract, and let's call it simple storage, and then curly braces, and inside we have the code of our smart contract. Okay, in the third icon here, if you go here, I think that you can put here, yeah, you can click here auto compile, and it will take the code and compile it and check the syntax. Okay, so I recommend to have this auto compile click here, and then you don't need to go back to this icon here, and we can just close it here. Okay, so well, this is a smart contract that a compiler 0.8 understands, but currently it does nothing because we don't have any function nor any storage. Okay, remember that our smart contract has two parts, and then with / we can put comments. This is something that is not translated into code, it's just for documentation, and here we need to define the storage, and here some functions, the functions of the smart contract. Okay, this is the anatomy of our smart contract. Always have this. Smart contracts always have these two parts: storage and functions. In our case, we said that we're going to use only one slot of storage, slot 0. Okay, but in this language, we don't use the notion of slot 0. We use the notion of a variable, and we are going to put here stored value. Okay, this name here is the name for slot 0, and I'm going to use it as an alias of the slot 0. It's a slot 0 because of the position that you define variables in the storage. Okay, so well, this is the storage. Okay, but it is complaining, the compiler, because it needs to, the Solidity compiler needs to know all the variables that you are using. I mean, which is the type of thing that you are storing in stored value, and we are going to store a unsigned integer. Okay, now it's not compiling. Now it's not complaining, and it's compiling. Sorry. So here what I'm saying is that, okay, in the slot 0, use the name stored value as an alias of the slot 0 of the storage, and in this slot 0 I'm going to store numbers that are of 256 bits and are positives, positive integer numbers. Okay, this is exactly what I'm saying here. And now we build a couple of functions, yeah, I'm going to build a function here to let's say function. Okay, I'm going to build a function, and we said that, okay, the easiest, I mean, I have one variable here, one storage here. I'm going to build around this a couple of functions, just one to set the value. So I'm going to say set storage value. Okay. And another function to get the storage value. At the moment, let's write them like this, and let's see. As you see, something is going wrong still, because yeah, we have something here in red. So, well, first is that set storage value. Okay, you need to call this function. I mean, to execute this function, you need to send a transaction to an instance of a smart contract deployed with this code. Okay, and for this to be possible, here we need to put that this function can be called with a transaction, and we say this by putting here, for example, public here. Okay, so I save it. Okay, and then what I want to do is I want to receive a transaction. When I deploy the smart contract, the instance of this smart contract will receive a transaction with the new value that we want to put here in this box here. Okay, so this function here needs to carry the value that we want to set in the stored value. So here this function is going to receive an argument that says new value. Okay, and then what we do is put the value, the value of a stored value, we put it to the new value that we are receiving in the transaction. So this is our first function. It's a function that can be publicly called. It means that we send a transaction to this function, and when and in this transaction we receive an argument, and this argument in fact is the new value that we want to set in the storage. Okay, and then let's see the function. Let's create another function that is going to do get stored value. Okay, this function is to obtain the value that is stored in the storage of the smart contract. The question is, it needs to receive any argument? No, because this function is going to be called to get the value in the storage. So we don't need to provide any value here. Okay, but this function is going to return a value. Okay, so we say this returns, and then what type of value we are returning. we're returning a positive number. This is what we are saying here. And also it's going to be public, and this function is not going to modify anything of the smart contract, or it is not going to modify anything of the state of the blockchain, because we are only returning the value of the storage of a smart contract, but we are not modifying anything. So when this is the case, we put here the keyword view. Okay, and what we do here is we return the storage value. Well, this is our first smart contract. This is the simplest possible smart contract, I would say. It's like the hello world of the smart contracts. I go through the code quite a little bit fast, but I'm going to use it, and as I use it, I'm going to explain again a little bit these functions here. So, okay, now this is my template. This is a template of my smart contract, and now what I need to do is to send a transaction to the network to create an instance of a smart contract based on this transaction, based on this template, sorry. So for this, you have this icon here, and here you can deploy and run transactions to smart contracts. And in fact, this tool is quite powerful. I mean, you can deploy smart contracts on a real network or on the main network of Ethereum. But this tool also provides us like a playground, and is this blockchain made of just one node, okay? It's just to play. So you can imagine this like a play environment, okay? Select here Remix VM, okay? And yeah, we get in this playing environment, we have different accounts with some amount of ether, okay, to just make some tests. And then what I need to do is to take this smart contract and just deploy the smart contract. Okay, if you go here and just we deploy the smart contract. Okay, when this is creating the it's taking this this template, the code of this template, and it is sending a transaction to the network. And when this transaction is executed, then all the nodes of the network will have the code, this code here. And if we go down here, we see that this tool, Remix, creates here a graphical interface to access or to interact with the smart contract. Okay, as you see here, the smart contract has been deployed in this address here. Okay, 0xD91. Okay. Okay, and now clicking at these two boxes, we can execute these two functions. Well, several questions here. First, if I click get stored value now, what I should get, because stored value is not initialized to anything here. Well, as I said, in Ethereum, when you check a variable that you haven't set before, in other languages you get undefined or null, or you can get some different some different ways of expressing that you haven't initialized your variable. But here, everything is initialized by default to their 0 values. Okay, so if I check here, I see a 0 here. Okay, despite I didn't say anything here. Okay, and now and now let's change the value, the value of this box. Okay, let's put here, I don't know, 56 for example, and let's execute this function. Okay, and if I check now, I see that it's 56. Okay, So, but let's select another account here. Okay, well, as you see, I did all these operations all using the account 5B3. Okay, and now I don't have 100 ether. I have less because, well, I have used I've been using the system, and I need to pay a fee for the execution. Okay, but okay, let's select this account AB8, which has 100 ethers. Okay, and let's try to change the value. Okay, if I click here and send, when I click here, what I'm doing in fact is sending a transaction. Okay, and as you see, I don't have 100 now. I have less because I have to pay a fee. Okay, because this transaction is modifying the state. But if I select now this other account 4B2 that has 100 ether, and now I check which is the current value of the storage of this smart contract, it says is 79. But if I go to the account, oh, I see that they didn't discount me anything. Okay, and this is because when you call functions, when you call a function that can modify the state, potentially can modify the state, then you have to pay a fee because state changes need to be paid. Okay, but if you call a function that is view, that you don't change, that is not going to change the state, then executing functions that are view, this is for free. I mean, writing in the blockchain has a cost and you have to pay a fee. Reading or executing a function that only reads the state, this is for free because there is no consensus needed here because you are not changing anything. Okay, so let's see in a picture what we did to summarize it. Okay, essentially we write this smart contract here, and in this smart contract, well, we only have two functions. Sorry, I think, well, this is a modification. I mean, we put it view here. Okay, and well, when we deploy the smart contract initially, we send that when we click deploy, we are sending a transaction to a network, and the code of the smart contract is replicated, is created in each node of the network. Okay, initially the storage is 0 everywhere. The storage of this smart contract is we are using one slot, and the value of this slot is 0 everywhere. Okay, so when we call get stored value the first time, we are just asking one of the nodes to tell, hey, call this function in this smart contract, call the function get stored value. Okay, and the node is just returning to us the current value that is 0. Okay, but to do this operation, to call a function that is view, that is not modifying the state, you don't need to pay anything. Then we modified the value. Then we modify the value of the state. For example, putting a 7 or 79. I don't know what I used. And yeah, for this you need to send a transaction. Set stored value is a function that is not view. It's a function that potentially can modify the state, and for this reason you need to pay a fee. And we send this transaction, and then we need to pay a fee for this. And when this transaction gets ordered in a block, finally executed by all the nodes on the network, and all the nodes of the network need to change this storage of this smart contract to this value. Okay, and then well, that's it. I mean, we pay because modifying the state is an operation that involves all the network and is an operation that must be consensuated. We need to reach consensus around when this operation is done, and all the nodes must do it at the same time. Okay. Well, just to finish, just a small change. Well, it is very typical to create view functions to get that return the value of storage slots. So essentially, you can put the keyword public here, and the compiler will generate a function like this. I mean, it will generate a function exactly like this, with the same name as the storage variable. So we can get rid of this because this is equivalent, and this is our final smart contract. Okay, which you cannot see it, but this is a view. Here we have a view function inside, and here we have a function that modifies a state. And yeah, to finish, you can deploy as many smart contracts as you want. Okay, and each time you deploy a smart contract, it gets deployed is a new instance at a new address with its own storage. Each instance has its own storage. The only thing that these two instances are sharing the same template or the same source code. And after seeing this very simple smart contract, we and see public state variables, we arrive to the end of this lecture, in which we have reviewed the main features of a blockchain, the concept of a smart contract, the anatomy of a smart contract that we said that has two parts, storage and functions. And we used a little bit the remix, the very basic functionality of the remix that allows us to write the smart contracts and to then interact with the blockchain with these smart contracts. We can deploy the smart contract and create instances of the template that we just programmed, and then we can also interact with the smart contract. And yeah, we created a very simple smart contract and deployed it and interact a little bit with it. So that's all on this lesson.